Hello, my name is Neelima Shrestha, and I am having this presentation on the topic of STEM, and inquiry-based learning in early childhood education. So my first slide is all about my introduction and the topic. So I have mentioned my course name, lecturer, and that. So it's only about my information. So we'll move on to the next slide, that is slide number 2. Slide 2, I have written the introduction to STEAM in early childhood. So what STEAM stands for. So I have written the meaning and how it's gonna help in the early childhood setup. So I have also mentioned this learning approach, how it relies on inquiry-based learning logic adapted to young children's development, and it helps in the overall development of child. So slide 2 it also has I have mentioned how STEM helps children to explore, investigate, and solve problems through play and hands-on experiment. So I have evaluated framework work as well here, and that explains that inquiry and play-based learning support children's overall development and also help to build critical thinking, communication, creativity, and collaboration in children. Uh, Moving on to slide 3. Slide 3, I have mentioned here what is intentional teaching. So I have elaborated here what intentional teaching is and how the goal-oriented and deliberate mindset of educator help to give more information to the children throughout the hands-on activity, and how educator plays the role of scaffolding and does the task to show the activity by providing the guidance, how it helps children to develop scientific thinking, curiosity, and confidence. So slide 4, I have explained the inquiry-based learning in STEAM. So in early childhood, how inquiry-based learning helps and how inquiry-based learning help to achieve outcome 4 and outcome 5 of EYLF. I have explained these here. So in slide 5, I have explained the activity. So here I have taken the activity of balloon static electricity investigation. So I have few drawings as well, if you want to move this one here. So I have 4 to 5 years old of target group of children, and the learning goal for this experience will be balloon static electricity. So this is related to science, and I have just elaborated how this activity gonna cover all the areas, so that we'll have science because it will be explaining static electricity and force. Technology will be using like different kind of materials and tools. So here we are using technology and engineering because it will be involving testing methods and problem solving, and mathematics because the children will be comparing, sorting, and recording the records. Our learning goal for the task is to explore the motion of objects and interaction of forces. So this activity allows children to verify the prediction and observe outcomes. Moving on to our next slide. So activity 6, I have mentioned how we're going to do it. So we have the list of materials that we'll be using and the procedure where the teacher will be showing how we gonna carry out the process. So in first, I have also mentioned few example of questions. The questions should be open-ended so that they have more questions, not yes no questions that will limit it the answer and the possibility. So few examples for open-ended questions are: what do you notice happening to the paper? Why do you think the paper moved? What happens if we rub the balloon longer? Or which materials work best? So these are the few examples, and I have given the examples of STEAM vocabulary. So how they gonna understand more, they gonna develop their more vocabulary and will understand the terms such as static electricity, repel, attract, predict, etc. So these are the few examples that they will understand, they will get to explore. So slide 7, I have shown how evaluative principle and practices like different outcomes are aligned. So since we are doing the activity, so it aligned with evaluative outcome 4. Children are confident and involved learners. So this type of children inquiry activity supports children's curiosity and creativity. So this slide also have like explains how children are confident and how they involve in the hands-on experience. And another one is EILF outcome number 5. Children are effective communicators. So while doing the activity, they will be communicating with educator, because educator will be giving the guidelines and the steps. So also not just only that, but children will also be interact with their peers, so that will help to improve their communication skills, and will also be learning more vocabulary. So this aligns with children, this aligns with EILF learning outcome 5. So we have slide 8. So slide 8 is basically like we are evaluating this learning experience. EILF 8 we have, sorry, slide 8 we have here, and slide 8 is like I have example like what they are learning throughout this activity. So by observing, so they will understand like how static electricity attracts paper. So children will develop observation skill, because while the educator will be scaffolding, so they will observe the whole task. And comparing, so they will understand like how different materials can cause different results. So they will understanding the concept of comparing, exploring explaining ideas, because the scientific vocabulary are being used, and also teacher will be explaining throughout the. So the last one is sharing discoveries with peers. Since every children will be doing their task individually, their collaboration, through the collaboration they will be communicating, and whatever they discover during the activity they will be sharing. So definitely they are the examples of learning I have mentioned. And going to the slide number 9. Slide number 9, I have given few examples how we can support diverse learners and indigenous perspective in our learning. So if there's any child with having any kind of visual impairment, so the demonstration here will show the visual demonstration. So it will help to the children to include in this inclusivity, and simplified operation guides will help them. We don't have much on indigenous perspective, but however, we can use the indigenous related materials, because if we are using indigenous perspective, then we can add more of the indigenous aspect, such as like we'll be including more of the natural things. Instead of balloon, we can add maybe some rough wood or something. So we can do that. And in the next slide, I have reflection. So reflection is like it I have listed the few strengths of the activity. So the activity is highly engaging and interactive. So I think this activity is very good for the children for 4 to 5 years, and it's going to support curiosity and experimentation. Another strength of the activity is it encourages communication and collaboration, and also promotes active inquiry learning. So areas of improvement, for this one, I think we can add more of the natural resources, and for the extension, we can introduce the magnetic research topics, or simple circuits, or outdoor science, which can give more information to the children. So these are what I have in our side, and the last slide is the references. Thank you so much.